Hi. Okay, so today we're going to look at product and quotient rules. Okay, so I'm going to present them both together, and we're going to use them both. So for the product rule, you might want to write this down because I'm going to scroll down from this page, so the rules won't always be visible. But what we have for the product rule is if y equals uv, where u is a function of x and y and v is a function of x. That's for all of these. U and v are functions of x. Then dy by dx equals u dash v plus u v dash. So I'm using a dash to indicate that we differentiate with respect to x. So if you're not familiar with that notation, it's used more, I think it's used a lot in physics, and you might have seen it in mechanics, but u dash means du by dx. Okay, so that's the product rule. Now for the quotient rule, this one is given in the formula book. However, I think it's worth memorizing because it's so similar to the product rule. It is the product rule, really. Any fraction can be rewritten as a product with the power -1. So if y equals u over v, the quotient rule says dy by dx. Now look how similar this is to the product rule. It's still u dash v and u v dash, except this time we're subtracting. Okay, so with the product rule, it didn't really matter which way around you did them. You could do v dash u first because you're just adding them, but with the quotient rule, we have to differentiate the numerator first, and then that will be divided by v squared. Okay, so I want us to memorize these essentially. That's okay. I wanted that to be a rectangle. It was so bad was my rectangle, the iPad didn't even recognize what shape I was trying to make. Okay, so we're going to be using those formulas again and again, so you might want to just make a note of them. And in order to try out using these formulas, I've pulled a few past paper questions from the Edexcel exam board. So let's have a look at some of these. So first we have to identify whether we're dealing with a product or a quotient. Okay, so if you want to have a go at these first, pause the video now, and then I'll go through them in a second. Or if you want to, for the first example, to just follow along with me, that's fine as well. So for this one, this is a product rule. So we're going to be dealing with u dash v plus u v dash. Now u, in this case, is x squared, and v is e to the x, 3x plus 2. So we could just put all those values straight into the formula. So if u is x squared, then u dash is 2x. V doesn't change, it still stays as e to the 3x plus 2. And then we plus u v dash. So u is x squared. V dash, we need to do the chain rule for this. So for the chain rule, if you remember, we pretend that the power of e is just x, so it stays the same. And then we differentiate that power and multiply. So we have to multiply by 3. So I'm going to put a 3 here in front of the whole thing. So that's what we get when we've differentiated 2x e to the 3x plus 2 plus 3x squared e to the 3x plus 2. We can simplify that a little bit by factorizing. So we could pull out a common factor of x from both of those terms and e to the 3x plus 2. If we take out x from that first term, we're left with 2, and e to the x plus 2 has been taken out, so that's all we've got, plus 3x. So that's our final answer with it all factorized for us. Note that on the exam, this was an older exam, but if the question was phrased exactly as it appears here, differentiate with respect to x, you would get full marks for that. Okay, there'd be no need for you to factorize in order to simplify the answer. That's because of the wording of the question. It's just asked you to differentiate, and when you get to that point, you have differentiated. Now, it's a good habit to get into is factorizing, because obviously the question could be phrased slightly differently. It could say, show that when you differentiate, you get this. So then you'd have to factorize. Or it could be asking you to find stationary points or something. So then you'd be solving an equation where this equals 0. And if you're making it equal 0, you want to factorize. So it's just a good habit to get into. But in this case, on this particular question, the factorizing would not get you any more marks. Okay, so for this one, the second one, we're dealing with a quotient here. So we're going to use u dash v minus uv dash all of v squared. And remember, u is the numerator, v is the denominator. So that will equal, okay, so for u dash, we have to use the chain rule. So cos becomes minus sine 2x squared cubed, sorry, and then we multiply by the derivative of the bracket, and the derivative of that bracket is 6x squared, so the 6x squared goes there. So that's u dash, and then we've got to multiply that by v. So I'm going to put it in brackets just so that we can kind of demonstrate that we're using the formula correctly. Minus uv dash, so u is cos 2x cubed, and then v dash will just be 3. So I might as well put the 3 there. That's all over v squared, which is 9x squared. Okay, now technically we have differentiated this, but it's not very tidy at all, so it will need a little bit of simplifying with this. So if we look at that first term, we've got 3x multiplied by 6x squared. So that will become minus 18x cubed sine of 2x cubed minus 3 cos 2x cubed all over 9x squared. And again, since the question just asked you to differentiate, that would be perfectly fine as your final answer. I think I might just divide top and bottom by minus 3. To get minus 6x cubed sine 2x cubed plus cos 2x cubed all over 3x squared. I've just put the minus outside the whole fraction. Yeah. Oops. Let's go to the next one. Okay. So again, pause the video and have a go at this. Okay. So hopefully you've had a go at this, and let's have a look at what you should have got. So for part A, we've got y equals x squared. I'm going to rewrite that square root so that it's got a power. 5x minus 1 to the half. So this one is a product rule. So we're going to be using u dash v plus u v dash. We'll be using that formula in order to find out dy by dx. So dy by dx equals, okay, so u dash is 2x. That will be multiplied by v. And then v dash, we need to use the chain rule. So we get a half times 5x minus 1 to the minus a half. And then we'll multiply that by 5. So that will give us 5 over 2. 5x minus 1 to the minus a half. And that's multiplied by u, which is x squared. Now, we need to find the value of dy by dx at the point x equals 2. Now, this is from an older exam where the examiner assumed you didn't have a calculator that could do this. This question would be rephrased in the modern syllabus because everybody has a calculator that can just evaluate dy by dx at certain points. However, that wouldn't, the question won't be phrased so that you could just plug it in and get the answer. It'll say show that the answer is something or something. Right, so we need to then, so one thing we could do here is simplify by factorizing, but rather than doing that, because we want to find it at a certain point, let's just sub 2 in now. So we get dy by dx at x equals 2 is going to be 4 times 5 times 2 minus 1, which is 9 to the half, plus 5 over 2 times 9 to the minus a half, times 2 squared, which is 4. 9 to the half is 3, so this becomes 12, plus 20, so 9 to the minus a half is 1 over 3, so this becomes 20 over 6. Which simplifies to, I might just get a bit of help from my calculator here. Uh, 92 over 6. Which is 46 over 3. And for part B, we're dealing with a quotient. So we're going to be using u dash v minus uv dash all over v squared. So u dash, we've got to differentiate sine of 2x. So that becomes 2 cos 2x. And we're multiplying that by v, which is x squared. And we take away uv dash, so that will be 2x sine 2x. All over v squared, which is x to the 4. And so if we simplify that, there is a common factor of x that we can cancel. So, oh, sorry, I cancelled it in the wrong place. So we've got 2x cos 2x minus 2 sine 2x all over x cubed. And here we might want to think about simplifying, see if there's any sort of trig, you know, identity we could do to simplify it. But again, looking at the way that the question's phrased, it says differentiate. So we've just got to differentiate it. We don't need to worry about it being in the simplest form possible. So that will do for our final answer there.